Distinguished ladies and gentlemen, let us find the eigenvalues of a 2 by 2 matrix. For example, given the matrix A, that is 5, 4, 1, 2. So I want us to find the eigenvalues of this matrix. So the first step that we will take is just that is A minus lambda I. That is the first step that we will take. So we subtract lambda I from A. That is, we subtract lambda I from the matrix given. So lambda I is just the product of lambda with the identity matrix, which has the same order as the matrix given. So this is a 2 by 2 matrix, and the identity matrix will also have the same order as the matrix given, that is 2 by 2. So in our scenario, we will do like this. That is 5, 1, 4, 2. Then we subtract with lambda times, the identity matrix here is just 1, 0, 0, 1. This is the identity matrix. So 5 minus lambda times 1. So this is what we will do. Let us first solve this. So we will have 5, 1, 4, 2. Then lambda times 1. So we have a minus here. So lambda times 1 will be lambda. Lambda times 0 will be 0. Then lambda times 0 will be 0. Lambda times 1 will be lambda. Then we have 5 minus lambda will be 5 minus lambda. Then 4 minus 0 will be 4. 1 minus 0 is 1. 2 minus lambda will be 2 minus lambda. That is what we have as our resultant matrix. That is A minus lambda I. Now, what we will do is just we find the determinant of this matrix, then we equate it to 0. So that is 5 minus lambda. That is the product of the main diagonal. Lambda minus, not lambda minus, but 5 minus lambda. This is the one that I'm writing. Then multiply with 2 minus lambda. Then minus the product of the elements of the secondary diagonal. That is 1 times 4 is 4 is equals to 0. We equate it with 0. So in this, arriving at this point, we have to open the bracket. We have to expand this. So we have 5 times 2, that is 10. Then 5 times negative lambda will be negative 5 lambda. Then we have negative lambda times 2, that is negative 2 lambda. Then negative lambda times negative lambda will be positive lambda squared. Then we have this minus 4 here is equals to 0. Now, arriving at that point, let us collect the like terms. We have lambda squared. This is the one that I've written, lambda squared. Then we have negative lambda minus 2 lambda will be negative 7 lambda. Then we have 10 minus 4 will be positive 6 is equals to 0. So this one is our characteristic equation. This is our characteristic equation that we have obtained. This is the characteristic equation because if you find the determinant of A minus lambda I and you equate it to 0, you obtain the characteristic equation. And before you obtain the characteristic equation, if you write this one only, that is A minus lambda I, that is the matrix minus lambda times the identity matrix, the whole of this is just the characteristic polynomial. So let us proceed to find for the value of lambda, because if we find the value of lambda, then that is the eigenvalue. And since this is a quadratic function, then it means that we have two possible values of lambda. So in this, let us solve using the factorization method. So whereby the sum is -7 and the product is 6. So we have, let us think of two numbers whereby when we sum them we get -7, and when we multiply them we get 6. The two numbers can be -6 and -1. These two numbers, when you sum them, you get -7, and when you multiply them, you get 6. So we will have lambda squared minus this 6 lambda minus lambda, then plus 6 equals to 0. So we will have lambda here into lambda minus 6, then minus 1 into lambda minus 6 is equals to 0. Therefore, here we will have lambda minus 6, then we have lambda minus 1 is equals to 0. Therefore, we can say that lambda minus 6 equals to 0, or lambda minus 1 is equals to 0. Therefore, our first eigenvalue can either be 6. Our first eigenvalue is 6, or it can be 1. And our second eigenvalue can either be 1 or 6. So you can write lambda 1 can either be 6, or lambda 1 can either be 1. Or you can also write lambda 2 can either be 6, or lambda 2 can either be 1. So that is how you can find the eigenvalues of a 2 by 2 matrix. So how I wish that you could subscribe to my YouTube channel. You can like and you can comment. Thank you.